In this video, we're going to continue to take a look at applications of normal distributions. However, this time, instead of trying to calculate probabilities that are associated with normal distributions, we're going to try to go the other direction. Right? And what I mean by that is we are going to start with probabilities, and we're going to try to calculate data values. We're going to use StatDisk, which is associated with the Triola series, which is the textbook that we're using. And so we are going to use this. So these will be our instructions if we are trying to calculate data values when we are given a probability or area. So let's look at an example. Here we have this information at the top. Men's heights are normally distributed with a mean of 69.5 and a standard deviation of 2.4. Women's heights are normally distributed with a mean of 63.8 and a standard deviation of 2.6. The U.S. Navy requires pilots to have heights between 62 and 78 inches. We're going to solve, shade, and draw and shade, and label the indicated region for each of these. So, we already went through problems 1 and 2 in the last video. If you want to take a look at those, you can see that. We're going to jump down to problem 3, which is a little bit different than the first two. So here, this asks, if the Navy changed their policy so all but the shortest 2% and tallest 2% of women were eligible, what would these new requirements be? So again, we are thinking about information dealing with women, and so women's heights are normally distributed. The mean for women's heights is, so this is the women's information, so that mean is 63.8. So this time, we are asking a different question than what we did last time. So we want to know what is the value here that separates the lowest 2%. Or 0.02. And we also then want to know what is the value here that separates the upper 2%. So if we want to do these, if we want to solve this, and we're going to use StatDisk as our technology tool to help us towards that, we are going to first identify the z-score that is associated with an area of 0.02 to the left. So if there's 0.02 to the left, the z-score is what? And we're going to go over to StatDisk, statdisk.org. And so here in StatDisk, I would choose analysis, probability distributions, normal distribution. This time we're trying to find a z-value. We don't know that. We do know the cumulative area from the left, right? So this tells us you need to input an area to the left, and that area to the left is 0.02. So we will evaluate that, and over here it will spit back a z-value. Our z-value is negative 2.05, we'll say 0.054. Negative 2.054, that is the z-value. Is the z-value the data value? No. To convert from a z-value to a data value, remember that we have our z-score formula, right? So our z-score formula says z is a data value minus the mean over the standard deviation. If we do a little bit of algebra here, we can solve for x for that data value. So we would multiply both sides by that standard deviation and then add the mean. So we have sigma times the z-value. So for us, we want to know what is the x value, what is the data value that is associated with this z-value and a mean and standard deviation for women. So the X value here that will separate the lower 2% of women is going to be 63.8. That was the mean height for women, plus the standard deviation. The standard deviation for women's heights was 2.6. And that is going to be multiplied by the Z value that we just calculated. And if we do that, we find out that this data value, 63.8 plus 2.6 times a negative 2.054, we find the height requirement here would be 58.46 inches. Right, so that would be the height requirement that would be on the lower end. On the upper end, we see that there's 2% here to the right of the value that we want. StatDisk asks us to input the area to the left of the value that we want. So if we know 2% is to the right, then 98% is to the left. And so in StatDisk, what we're going to do is we observe that there is 0.98 to the left of the value that we want. And so that Z value that has 0.98 to its left, let's go over to StatDisk. We're going to input this time a value of 0.98 and evaluate it. That gives us a value of positive 2.054. Some of you may observe that the last value we had was negative, this value is positive, but the numbers themselves are the same. Why is that happening? Well, when we have a standard normal distribution, which is what a z-score has, there is symmetry about the mean, about that value of 0. And so the value that has 2% to the left should be the negative, the exact opposite, have the opposite sign of the value that has 2% to the right. And that would be true for anything. The value that has 3% to the left is the z value with 3% to the left is the opposite sign of the z value that has 3% to the right. And you could go through that for each number. Once we change this, when we move away from a standard normal distribution to just regular normal distribution, we can't just negate this or take away negatives. That's a little bit weird. And so to find the x value, to find that data value, we're going to take x is the mean, 63.8, plus the standard deviation, 2.6, times the z value. The z value here won't have a negative this time. And we get something like 69.14. inches. And so our new requirements would be the heights should be between 58.46 inches and 69.14 inches. All right. In the next video, we're going to start talking about sampling distributions. We will see you there.